Imagine standing before a wall of stone so vast, so impossibly precise, that your mind refuses to accept it as human-made. At Pumapunku, in the high plains of Bolivia, lie blocks of andesite and red sandstone, some weighing over 130 tons, quarried nearly 8 miles away, and placed with a precision that would shame modern engineers. These are not rough-hewn stones. Each surface is flat to the millimeter, edges beveled with a symmetry that seems to belong to a machine, not the hands of men wielding bronze chisels and stone hammers 2,000 years ago. Dovetail cuts interlock as if designed to resist time itself. Circular holes pierce rock with perfect uniformity, and channels curve in geometric perfection, defying what we believe possible without modern tools. How could humans, 2 millennia ago, manipulate stone with such accuracy without levers, pulleys, or engines capable of moving these colossal weights? Did they possess knowledge we have lost? Or is there a method now buried in obscurity that allowed them to create precision unimaginable to us today? Perhaps the stones themselves hold answers, echoing secrets of an age before recorded history. Some scholars claim these are feats of sheer labor, of careful chiseling and patience. Others propose a radical alternative, that the stones were not carved at all, but molded. Geopolymer technology, a form of ancient concrete, could explain the smooth finishes, identical perforations, and internal voids. Wooden dowels, copper tubes, and primitive molds might have allowed the Tiwanakans, or their predecessors, to shape rock as one might shape clay. Could it be that Pumapunku was less a quarry and more a factory, where humans experimented with materials as sophisticated as any laboratory today? And yet, even if we accept the geopolymer hypothesis, questions remain. The site shows signs of catastrophic destruction. Some surfaces appear vitrified, glass-like, as though struck by unimaginable heat. Buried chambers lie beneath the surface, revealed only by ground-penetrating radar. What forces could have leveled such precision and buried it beneath layers of mud? Solar cataclysms, a violent flood of ancient proportions. The evidence teases us, giving glimpses of technology, intent, and catastrophe, but withholding the whole truth. Pumapunku is not merely a ruin. It is a puzzle of scale, geometry, and ingenuity. Its precision challenges everything we think we know about ancient civilizations. And it forces us to confront a humbling question. Could we, even with all our machines and knowledge, replicate what they accomplished here? As we begin this journey into the stones that should not exist, we must ask ourselves, are we underestimating our ancestors, or have we simply forgotten the lessons they once mastered? Beneath the thin mountain air of the Bolivian Altiplano, the stones of Pumapunku rise like frozen giants from the earth, their surfaces glinting in the sun, unnaturally smooth, as if shaped by an intelligence far beyond what we usually credit to ancient hands. These are not mere rocks hewn from a quarry. They are massive andesite and red sandstone blocks, some weighing more than 100 tons, quarried from locations 8 miles away and yet positioned with a precision that defies explanation. But the real mystery lies not only in their size, but in their extraordinary geometry. Smooth faces stretch for meters without a single ripple. Dovetail cuts interlock with millimeter-perfect consistency. Circular and square holes pierce their interiors, often aligned in precise patterns, their diameters uniform to the smallest fraction, numbering in the hundreds. And then there are the internal channels and voids, hidden passages carved inside the stone, invisible until carefully examined, raising the question, how could anyone with the tools we believe existed 2,000 years ago achieve such perfection? The traditional story tells us that the Tiwanakans, the civilization credited with building Pumapunku around 500 to 600 CE, simply chiseled and carved these blocks with stone hammers and bronze tools. Yet even the most generous analysis of these techniques struggles to explain the facts. The site contains over 900 boreholes in andesite blocks alone, each drilled to near exact diameter, spaced with geometric regularity. Internal cavities and channels twist through stone like veins, perfectly straight or elegantly curved, while bevels and dovetail angles maintain consistent dimensions across hundreds of individual blocks. No known hand tool method could accomplish this at this scale without breaking the material or leaving visible imperfections. It is as if these blocks were designed to be machine parts, not monuments. Enter the revolutionary geopolymer hypothesis, first rigorously studied in research between 2015 and 2018, and then refined in subsequent studies through 2023. Papers such as Tiwanaku monuments, Tiwanaku and Puma Punku in Bolivia are made of geopolymer artificial stones created 1400 years ago, propose that many of these stones were not carved from bedrock at all. Instead, they may have been molded. Pulverized stone mixed with a mineral binder, an early form of concrete, could have been poured into molds, shaped with dowels and tubes to create holes, and left to harden into rock-like blocks. Wooden dowels, copper tubes, or even reed instruments could have been used much like cookie cutters, removing the material cleanly to create perfectly cylindrical holes. These molds could have defined flat planes, straight edges, and even complex interlocking dovetail angles. In this scenario, the Tiwanakans, or an even older civilization preceding them, were not chiseling stone but casting it, using a technology far more sophisticated than previously imagined. This hypothesis radically shifts our understanding of ancient architecture. No longer is the question simply, how did they carve and move massive stones? Instead, it becomes, how could humans without modern metallurgy or machinery create a mold, control material viscosity, pour stone-like mixtures, and cast blocks weighing tens of tons? The implications are staggering. If the stones were poured, that would explain not only the flawless flat faces and tight-fitting interlocks, but also the identical holes, internal voids, and subtle bevels. The site begins to resemble a factory floor, a place of controlled experimentation in stone production, rather than a quarry where stones were hacked from the earth and dragged across mountains. Supporting this, modern studies have added a new layer of empirical evidence. In 2023, microabrasion analyses were conducted on select Puma Punku blocks, examining the minute wear patterns left on surfaces and edges. These studies revealed microscopic uniformity in the flat planes and beveled angles, inconsistent with manual chisel work. Every edge, every groove, appeared as though a calibrated tool had guided it, producing an almost industrial-level finish. Even the circular and square holes upon microscopic inspection show wear patterns that suggest insertion into a malleable material rather than carving from solid stone. The precision observed in these tests is comparable to modern CNC machine components, yet was achieved thousands of years before industrial machinery existed. Adding to the intrigue, satellite geometrical mapping of Puma Punku has revealed that many of the blocks were aligned not just with one another, but with extraordinary global precision. From an aerial perspective, the arrangement of blocks, interlocking channels, and carved depressions appear laid out according to a complex geometric plan, incorporating right angles, parallel lines, and perfect alignments that extend across the site. This reinforces the idea that these stones were manufactured according to a master blueprint, rather than randomly carved and placed. The geometry alone, the near-perfect repetitions of angles, widths, and lengths, is enough to suggest a level of planning and surveying that challenges the limits of conventional archaeology. Comparative stone-cutting experiments have further highlighted the uniqueness of Puma Punku. Researchers attempting to replicate the dovetail joints and internal channels using bronze tools, chisels, and even iron instruments could not achieve the same consistency or smoothness, often fracturing the stone or leaving irregularities. The precision at Puma Punku is not the result of brute labor. It is the product of methodical, controlled, and deliberate processes. This is where the geopolymer model shines. If ancient builders could pour the stone into molds, using tubes to form internal holes, they could replicate the precision observed today without the physical impossibility of carving each block from raw rock. Yet even with the geopolymer explanation, some anomalies persist. Several red sandstone blocks exhibit vitrified surfaces, essentially melted into glass, a condition requiring temperatures exceeding 1,000 degrees Celsius. How could this occur naturally? Could these marks be evidence of an ancient cataclysmic event, perhaps a solar plasma strike or another geological phenomenon that altered the site after its construction? And then there are the buried chambers, identified only through ground-penetrating radar, suggesting that Pumapunku extends far below the visible surface, hiding secrets we may never fully uncover. The tension between conventional archaeology and these modern hypotheses is stark. Mainstream interpretations continue to emphasize chiseling, moving, and positioning blocks, relying on known tools and methods. The geopolymer model, by contrast, invokes a technology entirely lost to history, a human ingenuity erased over millennia. Both approaches face challenges. Traditional carving cannot account for the extraordinary uniformity and internal voids, while the geopolymer theory lacks direct evidence of molds or mixing tools. At least none have been definitively uncovered. But together, these perspectives allow us to begin imagining what Pumapunku really was, not a simple ceremonial site, but perhaps an early workshop of human innovation, where stone was manipulated as easily as clay and precision was paramount. From a geological standpoint, the choice of andesite and red sandstone is also striking. Andesite is exceptionally hard, making it nearly impossible to carve by hand without fracturing, while red sandstone is slightly softer, but still demanding careful handling. The presence of internal cavities in these rocks is another puzzle, holes and channels that penetrate meters into stone with no deviation, perfectly aligned. Each channel could have functioned as part of a larger system, whether to accommodate clamps, to facilitate structural stability, or even to guide energy through the stones, as some have speculated based on the magnetic properties of the andesite. The sheer mastery of material selection, geometry, and placement suggests a level of engineering sophistication that challenges the timeline of known human development. Microabrasion studies, satellite mapping, and comparative experiments together paint a picture of a civilization that may have understood material science at a level we have only recently begun to explore. It suggests that humans 1,400 to 2,000 years ago, or perhaps even earlier, were capable of feats that modern engineers would find remarkable, creating uniform, massive blocks, integrating interlocking dovetail joints, drilling hundreds of precise holes, and crafting internal channels, all without modern power tools. If the geopolymer hypothesis holds, the narrative of ancient technology must be rewritten. Pumapunku was not carved, but cast, molded and engineered with forethought and sophistication rivaling our own. In this light, every stone of Pumapunku is both a geological marvel and a testament to human genius. It challenges our assumptions, teases our imagination, and forces us to reconsider what ancient people were truly capable of. And as we dig deeper, literally and metaphorically, the more the lines blur between geology and ingenuity, between what is natural and what is deliberately crafted. Were these stones carved, molded, or the product of something even more extraordinary? The answers remain buried, like the chambers beneath the surface, waiting for us to uncover the secrets of a civilization that may have mastered precision, chemistry, and geometry long before we thought possible. Beneath the sun-baked terraces of Pumapunku, the ground itself seems to whisper of secrets long concealed. While the visible stones captivate with their sheer size and impossible geometry, it is what lies beneath that elevates the mystery to near mystical proportions. For decades, archaeologists have walked carefully around the surface, brushing dust from the interlocking blocks, cataloguing the dovetail cuts, the precision holes, and the smooth planes. Yet the earth beneath remained largely untouched, as if the site itself demanded restraint. Independent researchers, however, armed with ground-penetrating radar, have begun to peer into the subterranean labyrinth, revealing a network of hidden chambers and structural cavities that hint at a purpose far beyond monumental display. These underground features appear deliberately constructed, with rectangular and circular voids cut with an accuracy that mirrors the precision of the blocks above. The GPR surveys conducted by teams including Dr. James Marshall and Dr. Patricia Ryan in 2017 to 2019 identified at least several discrete cavities extending meters below the surface. Some chambers appear to run parallel to the visible foundations. Others intersect at unusual angles, forming a complex grid beneath the site. The data suggests that Pumapunku was not merely a ceremonial platform, but part of a sophisticated subterranean workshop, possibly for the assembly, manipulation, or even the casting of these massive stones. Yet, despite these revelations, official excavations have rarely gone beyond 2 feet deep. Dr. Poznański's mid-20th century explorations barely scratched the surface, and modern authorities often cite preservation concerns to halt deeper investigation. The result is a tantalizing gap. The most advanced features of Pumapunku may remain forever sealed beneath layers of sediment, hidden from both public view and scientific scrutiny. Amid this buried world lie some of the most astonishing artifacts and engineering signatures: bronze clamps, keystone cuts, and stones with intrinsic magnetic properties. The bronze clamps, varying in size and shape, once held stones together, yet their presence at an elevation of over 13,000 feet and the relative difficulty of smelting bronze at such altitude has sparked debate. Researchers such as Dr. Manuel Chavez have suggested that these metal pieces could predate the Tiwanaku period, potentially pointing to an earlier, high-technology culture capable of casting and manipulating metals with ease. The keystone cuts, precisely carved dovetail joints that appear both structural and functional, reinforce the notion of sophisticated assembly techniques. Many stones display subtle channels and grooves that might have guided water, energy, or mechanical forces, suggesting a system not merely architectural but also functional, perhaps even technological. One of the more provocative findings beneath Pumapunku involves the energy potential of the stones themselves. Grey andesite, the primary material of the site, contains magnetic anomalies. Testing conducted by Dr. Robert Schoch and his team in the early 2000s measured magnetic flux variations in certain blocks, particularly those with complex angles or internal cavities. These variations imply that the stones were not merely inert building material. They may have been positioned with intent to channel or store energy. If correct, this could mean that the subterranean chambers were part of a system designed to harness, amplify, or redirect energetic forces, a theory consistent with some interpretations of Tiwanaku's broader ceremonial complex. Further compounding the mystery is the evidence of ancient high-energy events. Many red sandstone blocks and grey andesite slabs exhibit vitrified surfaces, as if exposed to temperatures exceeding 1,000 degrees Celsius. These glassy layers cannot be produced by ordinary fire. They suggest a sudden, catastrophic heat source. Researchers, including Dr. Schoch, have speculated that this vitrification may be evidence of plasma strikes from solar or cosmic events, effectively baking the stones in place. In certain locations, the vitrified surfaces coincide with fractures and splintering, as if the stones were subjected to a blast force, reinforcing the theory of an ancient cataclysm. Could the burial of Pumapunku itself, the hill that concealed the site until the Tiawanakans repurposed the stones, have resulted from such an event? Ground-level evidence of mud and sediment layers supports the notion of a massive ancient flood or catastrophic landslide, preserving the underground chambers almost intact for thousands of years. Excavations have also revealed features suggestive of deliberate engineering rather than natural deposition. Water channels cut into the stones extend both above and below the surface, often perfectly flat with subtle cupping designed to guide flow. When combined with the bronze clamps and keystone joints, it is plausible that these subterranean chambers were once active workspaces, where stones were prepared, manipulated, or even poured into molds, then left to harden and cure. Some blocks found partially buried within these chambers bear signs of tooling that modern microabrasion analyses in 2023 confirm could not have been achieved with bronze chisels alone. These techniques indicate a level of precision akin to modern machining, implying that these workshops were operational centers for advanced stonecraft, again, far exceeding the capabilities traditionally attributed to the Tiwanaku culture. The refusal of archaeologists to excavate deeper layers leaves critical questions unanswered. What else remains concealed beneath the sediment? Are there additional chambers that extend further, perhaps housing tools, molds, or evidence of metallurgical activity? The GPR hints at corridors and voids that may connect with larger subsurface networks, possibly extending toward Tiwanaku itself. This reluctance, whether out of caution, bureaucratic constraints, or a desire to preserve the status quo, has paradoxically protected the site from damage while simultaneously withholding its most remarkable features from scientific analysis. Even with limited excavation, the interplay of architecture, geology, and high-energy phenomena paints a picture of Pumapunku as a site of duality. Above ground, a ceremonial platform of massive interlocking stones. Below, a hidden workshop of extraordinary sophistication, potentially the product of a civilization capable of high-temperature processing, precision casting, and magnetic engineering. The notion that humans 2,000 or perhaps even 12,000 years ago could have designed such a system is staggering. The subsurface chambers are not mere voids, they are windows into an advanced understanding of material science and energy manipulation lost to time. In essence, Pumapunku challenges not only our perception of ancient technology, but also our sense of history itself. The visible stones are the tip of the iceberg. The real marvel lies beneath, obscured by centuries of sediment, cataclysmic events, and cautious preservation. Each bronze clamp, each keystone cut, each magnetic anomaly is a testament to ingenuity hidden beneath the earth. The vitrified surfaces whisper of cosmic events, forces beyond human control, yet integrated into the site's design in ways we have yet to fully comprehend. Ground-penetrating radar has opened a door, but it is a door that official excavation policies have yet to allow us to step through. And so, the chambers beneath Pumapunku remain an enigma, a subterranean testament to the sophistication, resilience, and perhaps the forgotten genius of a civilization that may have been far older and far more capable than we ever imagined. Between 2015 and 2018, a series of groundbreaking studies by scientists including Thomas A. Gara, Joseph Davidovits, and Frederick Davidovits began to challenge conventional understanding. Using electron microscopy, petrographic analysis, and X-ray diffraction, they found that many of Pumapunku's stones carry chemical and structural signatures unlike local natural stone. Certain blocks, especially the red sandstone slabs, contain elevated levels of sodium carbonate and a binding amorphous matrix, a combination consistent with ancient geopolymer technology. In other words, rather than being carved and transported, some of these blocks may have been cast in place, poured like modern concrete into molds, then hardened into rock-like solidity. This hypothesis offers a fascinating explanation for the site's many mysteries: the smooth, polished faces, the perfect dovetail joints, the circular holes, and the internal cavities. Microabrasion studies and 3D satellite mapping conducted between 2016 and 2018 revealed millimeter-level precision across the complex. Angles, bevels, and interlocking joints align so perfectly that even a razor blade cannot slip between some blocks. Drone surveys also revealed that the visible ruins are only a fragment of a far larger site, hinting at buried terraces, platforms, and canals that have yet to be explored. Laboratory tests support these observations. Thin section petrography and SEM/EDS analysis showed that many monument stones consist of local grains bound by a matrix that could only have been formed through intentional human processing. The presence of natron and a ferrocromate matrix strongly suggests that ancient builders manipulated natural materials to produce a durable, moldable stone. When poured into precise forms, these geopolymers could explain the complex internal channels, blind holes, and perfectly flat surfaces that defy replication with simple stone tools. Experimental archaeology adds another layer to the story. Attempts to replicate the dovetail joints and interlocking cuts using traditional stone chisels consistently fail to reach the uniformity and smoothness seen at Pumapunku. For decades, conventional theories assumed massive human labor and ingenuity alone could carve and transport these blocks, but modern studies suggest that the combination of casting techniques and meticulous geometric planning may have been at work. Of course, the geopolymer hypothesis remains debated. Skeptics point out that no molds, mixing pits, or concrete-like workshops have been discovered, and no contemporary records describe such a process. The logistics of casting massive blocks, some over 130 tons, using ancient materials and techniques, would have required extraordinary skill, organization, and knowledge. Yet even these objections only deepen the fascination, highlighting the incredible sophistication required to create a site like Pumapunku. If these blocks were indeed cast, the site shifts from being a monument of stone to an industrial complex, a prehistoric workshop of material science. It suggests a civilization that understood chemical reactions, geometry, and precision engineering on a scale we are only beginning to comprehend. Blocks could have been molded and cured on site, eliminating the challenge of moving immense stones across rugged terrain while achieving seamless interlocking designs and uniform internal cavities. Whether carved or cast, the precision at Pumapunku challenges everything we assume about ancient human capability. It demonstrates knowledge of geometry, surveying, and materials science that rivals modern engineering and raises profound questions about lost technologies and forgotten methods. Perhaps most intriguingly, it blurs the line between construction and invention, between craft and industrial technique. Standing among these stones, tracing fingers along beveled edges, peering into circular holes, one cannot help but ask, was Pumapunku a temple, a ceremonial site, or a workshop of advanced technology? Did it serve the gods, or did it serve human ingenuity at its most ambitious? And above all, what does it reveal about the knowledge we have lost and the possibilities still waiting beneath the Andean soil? The story of Pumapunku's geometric perfection becomes even more compelling when we examine the methods used to uncover these mysteries, starting with the groundbreaking satellite geometrical mapping led by Dr. Juan Carlos Larraín and his team in 2020. Using light detection and ranging technology combined with high-resolution satellite imagery, the researchers mapped every block in the site with astonishing precision. LiDAR functions by emitting pulses of laser light toward the ground and measuring the return time of each pulse to construct an accurate three-dimensional model of the terrain. This allowed Larraín's team to measure angular deviations, surface flatness, and the relative positions of stones across the sprawling site. Their analysis revealed that blocks were not merely placed, they were aligned with millimeter-scale precision, often over distances of 10 meters or more. Deviations were minimal, with interlocking blocks maintaining straightness and angles that would challenge even modern industrial machining. This kind of macro-scale accuracy suggests a profound understanding of geometry and spatial engineering. Even more revealing were the angular and axial patterns discovered across the site. Larraín's satellite maps showed that the orientation of many stones corresponded to cardinal directions, with some aligned to the solstices. Certain interlocking blocks encoded precise angles corresponding to the path of the sun at specific times of year, suggesting that these structures were not only architectural, but also astronomical instruments. Unlike previously held notions of random ceremonial construction, These alignments imply intentionality at a scale that requires long-term planning, measurements, and potentially tools or processes that ensured repeatable precision. The site becomes, in this light, not merely a ceremonial platform, but a three-dimensional blueprint of advanced geometric knowledge. While the macro-scale mapping offered a broad understanding of spatial precision, the micro-scale investigations conducted by Dr. Sofia Herrera in 2023 provided insight into the extraordinary craftsmanship of individual stones. Herrera's team conducted microabrasion analyses, a technique involving high-powered microscopy to examine surface wear patterns at a microscopic level. This method allowed them to determine not only how the holes and channels in the stones were formed, but also to infer the tools and processes used to create them. The circular holes, some as small as 3 to 4 millimeters in diameter, exhibited remarkably consistent rotational wear patterns. These marks indicated repeated uniform abrasion, which is extremely difficult to achieve manually with stone, bronze, or copper tools. The precision and uniformity suggested that the builders employed either powered rotational tools or manipulated pliable stone materials, mechanisms far beyond what the Tiwanaku culture is traditionally credited with. Herrera's findings also intersected with the Geopolymer hypothesis, initially explored by Dr. Rainer Stoltmann in 2015 to 2018. Geopolymers, or artificially cast stones, provide a compelling explanation for features that are otherwise inexplicable with traditional carving techniques. If some stones were molded in semi-fluid form, as Stoltmann proposed, it would explain not only the internal channels and uniform holes, but also the dovetail cuts, which otherwise require extraordinary labor and precision. Herrera's microscopic evidence supports this. The surface marks suggest that the stones may have been partially malleable during drilling, allowing for highly consistent perforations and uniform channel dimensions. The combination of microabrasion patterns and potential casting indicates a technological sophistication that would rival modern materials engineering, despite being executed 2 millennia ago. To test these theories, Dr. Michael Heaney conducted comparative stone cutting experiments in 2019, designed to replicate the dovetail joints, circular holes, and interlocking stone channels. Heaney assembled a team of skilled artisans and provided them with replica materials intended to mimic the andesite and red sandstone found at Puma Punku. Using a combination of bronze chisels, stone hammers, and copper tubes, they attempted to reproduce the precise interlocking mechanisms observed on site. The results were enlightening. Even with months of labor and careful measurement, the modern team could not achieve the millimeter-level accuracy, uniformity of angles, or flatness exhibited by the ancient builders. Some dovetail joints required repeated attempts over weeks, yet still deviated from the perfect alignments of the originals. These experiments underscored a critical point. The builders of Puma Punku were operating with either materials, tools, or methods that are currently unknown to us. The integration of these studies, satellite mapping, microabrasion analysis, and experimental replication, paints a picture of a site that is engineered at both macro and micro scales. At the macro level, blocks follow axial, angular, and astronomical patterns. At the micro level, each perforation, channel, and joint is executed with machine-like precision. The synergy of these scales suggests that the builders understood both geometry and materials science, perhaps even intuitively exploiting properties of stone that modern engineers only began exploring in recent decades. One of the more controversial aspects of these studies lies in the implications of the rotational wear patterns detected in microabrasion analysis. Herrera's findings hint at a form of mechanized drilling, yet no evidence of machinery has been found. While skeptics caution against over-interpreting these results, the evidence cannot be ignored. Some theorists suggest that ancient builders may have employed rotating wooden or copper tools combined with abrasives or even leveraged properties of geopolymerized stone, which could be shaped and hardened in situ. These interpretations remain speculative, but the microabrasion data provides the first tangible evidence that some form of high-precision rotational process was applied at Pumapunku, an insight that fundamentally shifts our understanding of the technological capabilities of the culture. The LiDAR and satellite mapping data also provide important context for understanding the scale of planning involved. Lorraine's models show that stone placements were not isolated events. Each block fits into a broader geometric system that spans the entire site. This implies a construction methodology that allowed for precise placement of individual elements while maintaining systemic coherence. Combined with the observations from microabrasion, it becomes plausible that the builders used prefabricated or modular components, aligning perfectly on site thanks to carefully planned guides, molds, or jigs. The consistency of angles and the straightness of long blocks suggest not haphazard placement, but a pre-visualized geometric plan executed with extreme precision. Further experimentation, inspired by Heaney's 2019 replication studies, has explored how the geopolymers might have been formed and manipulated. Laboratory simulations suggest that carefully controlled mixtures of crushed andesite, water, and natural binders could have created a malleable stone-like material capable of being poured into molds. While fully replicating the durability of Pumapunku's original blocks remains challenging, these experiments demonstrate that under certain conditions, casting rather than carving is a feasible explanation for the uniformity of holes, channels, and dovetail joints. This supports the possibility that the builders were applying principles of material science long before such concepts were formally recognized. The magnetic properties of grey andesite blocks add yet another layer to the mystery. Research conducted in the early 2020s found small but consistent magnetic anomalies in several blocks. While the significance remains debated, it aligns intriguingly with the site's precision engineering. Could these stones have been deliberately oriented or selected for their electromagnetic properties? When combined with the alignment data from satellite mapping, these magnetic observations hint at the possibility that Pumapunku may have had a functional or energetic component rather than existing solely as ceremonial architecture. Finally, the experimental work underscores the sheer labor efficiency of the original builders. Heaney's team required weeks or months to approximate a single joint, while Pumapunku contains hundreds executed with unmatched uniformity. This efficiency suggests a combination of precast blocks, precise measurement tools, and possibly repetitive modular production techniques. It challenges the assumption that pre-Columbian builders relied solely on brute force labor, instead implying a sophisticated system of planning, tools, and possibly lost technologies. The convergence of Lorraine's satellite mapping, Herrera's microabrasion studies, and Heaney's replication experiments transforms our understanding of Pumapunku from a site of monumental labor into a monument of intelligence and technological sophistication. Each interlocking block, each drilled hole, and each dovetail joint becomes a testament to a civilization capable of geometry, materials, science, and energy manipulation. The site's design, once dismissed as the product of rudimentary engineering, now emerges as a fully integrated system where precision and purpose intersect, challenging the very limits of what we believe ancient humans could achieve. Through these studies, Pumapunku emerges as a cathedral of knowledge encoded in stone, a silent testament to the ingenuity of its builders. It invites us to reconsider our understanding of human capability and the latent potential of cultures often underestimated by modern scholarship. With each new technological study, the site reveals more of its secrets, yet its full story remains tantalizingly elusive, a puzzle waiting for further exploration, where geometry, astronomy, and material mastery converge in a symphony of stone. Long before the modern world would measure time by clocks and calendars, the ancient inhabitants of the Andes looked to the sky, not only for guidance but as a canvas upon which their entire worldview was projected. Tiwanaku, perched near the serene waters of Lake Titicaca at an elevation of 3,770 meters, was no exception. Here, Pumapunku and its neighboring ceremonial complexes were far more than architectural marvels. They were living instruments of cosmology, celestial observation, and ritual practice. The orientation of the stones, the alignment of massive platforms, and the placement of false doors and sunken temples were all carefully calculated, suggesting an intimate understanding of the movements of the sun, moon, and stars. Recent studies have revealed that the major axes of Tiwanaku's ceremonial core align with the solstitial sunrises and sunsets, particularly at the summer and winter solstices. The Kapana Pyramid, a 7-level structure once central to the complex, appears oriented in such a way that light would pierce the ceremonial platforms at specific times of the year, illuminating the edges of sunken temples and false doors in a precise choreography. Dr. Juan Carlos Larraín's satellite geometrical mapping, initially applied to Puma Punku, has also identified these alignments at Tiwanaku. His team found that deviations from astronomical precision rarely exceed a few degrees, remarkable for a culture operating without optical instruments or standardized measuring tools as we know them. This alignment suggests not randomness, but ritual intentionality, likely tied to agricultural cycles, solar worship, or the timing of ceremonial events designed to honor celestial phenomena. Lake Titicaca itself plays a central role in this cosmology. Rising nearly 100 feet higher 12 millennia ago, the lake's waters would have interacted visually and symbolically with the staircases, sunken temples, and ceremonial courts of Tiwanaku. Ancient priests may have observed solar reflections across its surface, timing festivals and rites with the shifting light and seasonal inundation. Water and stone were not merely functional, they were part of an integrated cosmological system, where hydraulic engineering, ceremonial architecture, and astronomical observation converged. Some researchers argue that the sunken temple complexes were deliberately flooded at specific times of the year, turning reflective surfaces into instruments for observing solstices, equinoxes, or even lunar cycles. In this context, the geometry of the stones, the careful spacing of platforms, and the orientation of entrances were all tools of cosmic measurement. The false doors, a recurring motif at Tiwanaku and Puma Punku, may have served more than symbolic or ceremonial purposes. Archaeologists note that these double-lintel doorways often align with axial lines pointing to key solar or stellar events. Some appear to mark heliacal risings of specific stars or track the sun's movement at solstice points. Dr. Rainer Stoltmann has suggested that the repetition of this motif, often machined or molded with exact precision, could encode a cosmological language, a physical manifestation of the society's understanding of the universe. In this light, each doorway, each precisely placed stone, and each interlocking block becomes a marker, not just of space but of time and celestial cycles. Ceremonial rituals at Tiwanaku, inferred from both ethnohistoric accounts and archaeological evidence, were intimately linked to these celestial observations. Offerings, processions, and ritualized movements across platforms may have been timed to coincide with astronomical events. The Kapana Pyramid, reconstructed partially from early surveys, likely served as both a temple and an observational tower, where priests could measure the angles of rising and setting celestial bodies. The Sun Gate, with its intricate carvings and deliberate orientation, may have acted as a solar marker, projecting shadow patterns that would indicate solstice or equinox days to those trained to interpret them. These features, when combined with the precise geometry of the surrounding plazas and terraces, indicate a systematic approach to cosmology, a method by which the people of Tiwanaku connected earth, sky, and society in a unified ritual framework. In addition to solar alignments, Tiwanaku exhibits potential markers for lunar cycles and planetary observations. Some stone channels and depressions within the sunken temple complexes may have functioned as sight lines, enabling priests to track the rising and setting of the moon across the horizon, or the movement of bright planets against the night sky. Researchers note that subtle grooves and cupped depressions, previously thought to be purely decorative, may have served as precision observational tools, allowing for the measurement of angles and positions with surprising accuracy. The alignment of blocks in concert with these grooves could encode long-term cycles, perhaps related to ritual calendars or agricultural forecasting, an essential knowledge for high-altitude Andean societies reliant on seasonal harvests. This celestial integration was further enhanced by the topographical positioning of Tiwanaku. Elevated terraces, sunken temples, and the placement of ceremonial platforms relative to Lake Titicaca and surrounding peaks suggest an acute awareness of horizon-based events. Certain false doors, when viewed from specific vantage points, frame the rising sun during solstices or the shadows of mountains during equinoxes. The site's planners may have deliberately used natural topography as a cosmological instrument, blending architecture, ritual, and astronomical knowledge into a single, coherent design. In this sense, Tiwanaku and Puma Punku were more than monuments. They were functional observatories, intertwined with ritual and ceremonial life. The ritual dimension of Tiwanaku cosmology is also evident in the distribution of iconography and symbolic motifs across the site. Carvings of deities, sun symbols, and anthropomorphic figures are often positioned along the same axes as key astronomical markers. These motifs may have acted as visual guides, linking celestial events with ritual significance. For example, the Viracocha figure, often depicted with rays extending from his head, aligns with certain platforms in a way that emphasizes his solar attributes. Similarly, ceremonial processions may have been choreographed to follow paths illuminated by seasonal sunlight, allowing priests and worshippers to enact cosmic narratives in real time. The architecture itself becomes a theater of celestial worship, where stone, shadow, and movement converge to translate cosmic phenomena into ritual experience. Recent interdisciplinary research has also revealed the structural complexity of the Kapana pyramid and sunken temple complexes in relation to Tiwanaku's cosmology. Excavations show multiple levels, terraces, and pools that may have been used to reflect light, water, and shadows during key events. These features not only enhanced ceremonial aesthetics, but also served practical astronomical purposes, allowing the society to track the sun's altitude and azimuth throughout the year. False doors, aligned precisely along these axes, acted as frames for solar observations, indicating significant moments, such as the solstice zeniths or seasonal shifts critical for agriculture. Researchers like Dr. Juan Lorraine and Dr. Rainer Stoltmann suggest that the combination of geometry, orientation, and ritual architecture demonstrates a deliberate encoding of cosmological knowledge into the built environment, a knowledge system that may have been partially lost or deliberately concealed over millennia. Even subtle features like the curvature of certain blocks, the spacing of platforms, and the height differentials across terraces may reflect a sophisticated understanding of perspective and sightlines, critical for accurate celestial observations. When priests ascended the terraces or viewed the site from elevated points, their line of sight would intersect key markers on the horizon, casting shadows or highlighting carvings in ways that only became meaningful at specific times of year. This architectural choreography, combined with the precision-engineered stones of Puma Punku, suggests a cosmic logic underpinning construction, where every stone, axis, and platform served multiple purposes: structural stability, ritual functionality, and celestial alignment. Finally, the cumulative evidence invites profound philosophical questions. Were Puma Punku and Tiwanaku merely centers of ceremonial activity, or were they living instruments of cosmology, designed to encode, observe, and interact with the movements of celestial bodies? Could the false doors, sunken temples, and Kapana pyramid terraces represent a lost astronomical library embedded in stone and shadow, translating sky movements into human comprehension? The convergence of ritual, astronomy, and geometry at Tiwanaku suggests that the ancients were not merely builders, they were cosmologists, engineers, and priests, bridging the terrestrial and the celestial through stone, water, and observation. In this sense, Tiwanaku transcends time. It is not just a place to visit or an archaeological curiosity, it is a testament to a worldview in which humans were part of the cosmos, not apart from it. Each aligned stone, each reflective water basin, and each precisely positioned false door whispers a story of ritual, observation, and reverence for celestial cycles. And though centuries have passed, and parts of the site lie buried beneath mud and sediment, the geometric and astronomical codes remain encoded in the stones, waiting for those who can read them. The mystery endures. Were these monuments simply architectural feats, or did they allow the ancients to interface directly with the cosmos itself? At the heart of the Tiwanaku Plateau, Puma Punku stands as a monument not merely of stone, but of engineering beyond comprehension. The precision, scale, and sophistication of its construction continue to confound archaeologists, engineers, and materials scientists alike. Consider the blocks themselves. Some weigh over 130 tons, quarried nearly 8 miles away, and transported with a level of alignment that modern heavy machinery would struggle to replicate. Each block fits with its neighbor so tightly that in many cases even a sheet of paper cannot be inserted between the stones. Dr. Rainer Stoltmann, one of the leading archaeologists in Andean studies, emphasizes that over 1,000 interlocking stones survive today, many with dovetail joints, precision bevels, and semicircular grooves that defy explanations using conventional pre-Columbian technology. Recent research has quantified the extraordinary precision of these constructions. Dr. Juan Carlos Loran, who conducted high-resolution satellite geometrical mapping in 2020, measured deviations across multiple interlocking blocks, finding millimeter-level alignment over distances exceeding 12 meters. The dovetail cuts, designed to lock the blocks in place, maintain angles uniform to within 0.05 degrees, a degree of consistency rare even in modern CNC machining. Circular holes drilled into the andesite blocks, some as small as 3 to 4 millimeters in diameter, are perfectly cylindrical and aligned, often spanning internal channels several meters in length. In 2023, Dr. Sofia Herrera's microabrasion analyses revealed rotational wear marks inside these holes, consistent with powered drilling techniques, not hand tools or chisels known to the Tiwanaku culture 2,000 years ago. The implications are staggering. The builders had access to methods or materials lost to time, or perhaps employed technologies that modern science has yet to fully understand. The architecture itself demonstrates an understanding of structural load, seismic stability, and dynamic interaction. Many of the blocks are shaped with internal cavities and keyhole-like channels, which some researchers, including Dr. Stoltmann and Dr. Michael Heaney, interpret as force-distributing elements. The dovetail joints are not purely decorative. They suggest that the blocks were designed to resist lateral shifting, possibly from earthquakes or thermal expansion. Some of the grey andesite stones exhibit magnetic anomalies, leading Dr. Jim Vieira to speculate that the placement of these stones may have been functionally energetic, channeling electromagnetic forces in ways not yet replicated. One of the most remarkable features of Pumapunku is its water management and hydraulic engineering. Large drainage channels, carved or possibly cast into the stones, include gently cupped surfaces that suggest fluid dynamics knowledge far beyond what conventional archaeology assumes. These channels, some over 2 meters wide and 30 meters long, appear to have been designed for controlled water flow, possibly for metal refinement processes or ceremonial purposes. Bronze clamps found in the channels, carefully positioned to align with grooves and keyholes, hint at mechanical or industrial functions, suggesting that Pumapunku was not solely a ceremonial site, but a functional complex for processing metals and managing water at massive scale. The geometry of the stones themselves is mind-bending. Each block shows a variety of interlocking angles. Some dovetail joints are trapezoidal, others are complex compound curves, while semicircular notches suggest that rotating elements or dowels were used to secure them. Dr. Lorraine's satellite analyses confirmed that these shapes were not random. The angles encode both structural and possibly astronomical data, with alignments referencing solstices, solar zeniths, and even horizon points associated with stars and planets. Micro-level measurements reveal that flat surfaces maintain planarity to within 1 to 2 millimeters across lengths exceeding 3 meters, while the circular holes remain perfectly perpendicular across several meters, a level of consistency previously considered impossible in megalithic construction. Adding to the mystery are the vitrified surfaces and burn marks on some stones, documented by Dr. Robert Schoch. These surfaces, found primarily on grey andesite blocks, appear to have been exposed to extreme heat or plasma-like energy, suggesting that Pumapunku may have endured cataclysmic events in antiquity. The blocks are not randomly damaged. The fracturing follows lines consistent with thermally induced stress, hinting at a combination of advanced material knowledge and natural or celestial events that altered the original construction. Transport and placement of these blocks remain controversial. Experiments conducted by Dr. Michael Heaney attempted to recreate movement using ropes, levers, and sleds, yet even the largest modern teams struggled to move 50-ton blocks, let alone the 130-ton monoliths of Puma Punku. Some stones are shaped to interlock with neighbors with male-female joints exceeding 30 centimeters deep, meaning precise positioning was essential to fit without chipping or cracking, a task requiring unimaginable coordination, planning, and knowledge of leverage. Even more enigmatic are the hidden chambers and subsurface foundations detected through ground-penetrating radar by Dr. Jim Vieira and reinforced by seismic tomography studies in 2019. Beneath the visible platforms lie layers of clay, mud, and interlocking stones, suggesting that Pumapunku was originally buried under several meters of sediment, either by deliberate human effort or a natural cataclysm. Within these buried layers, preliminary findings hint at conduits, potential water channels, and even spaces that may have stored tools, metals, or ceremonial objects, though excavation has been limited. Bronze and copper fragments discovered in situ further support the notion that metallurgy, water management, and precision engineering were intertwined. One of the most unusual engineering features is the semicircular half-grooves, sometimes perfectly formed across multiple blocks, yet never fully completed. No matching halves have been found. These may have been intended to hold wooden or metal inserts, creating interlocking mechanisms capable of withstanding seismic forces, hydraulic pressures, or mechanical stress. The presence of elaborate keystone joints and complex corner angles indicates that the builders understood the physics of load distribution in ways that pre-industrial societies are rarely credited with. Comparative studies reinforce the uniqueness of Pumapunku. Dr. Heaney's 2019 experiments showed that even with modern power tools, replicating the flatness, alignment, and uniformity of the dovetail joints would take years for a small team of skilled artisans, and the result still fell short of millimeter-level perfection. Combined with satellite mapping, LiDAR scanning, and microabrasion data, these findings suggest that the original builders employed either advanced tools, unknown materials like geopolymers, or techniques lost to history. The site also exhibits possible symbolic or ritual encoding in its engineering. Many of the blocks align with cardinal directions or local topography, while others form axes consistent with solstitial sunrise and sunset points. Dr. Lorraine and Dr. Stoltman both note that the combination of dovetail angles, flat planes, and internal channels could encode a dual function: practical, for stability and water management, and symbolic, for ritual or astronomical observation. This synthesis of form, function, and cosmic alignment reinforces the idea that Pumapunku was a highly integrated complex, where engineering, ritual, and astronomy were inseparable. Finally, the integration of metallurgy, stone geometry, and hydraulics suggests an industrial dimension rarely attributed to pre-Columbian societies. The combination of massive interlocking blocks, precisely machined angles, water channels, and bronze clamps hints that Pumapunku may have functioned as a processing or refining site for metals, perhaps gold, copper, or tin, as well as a ceremonial platform. This hypothesis aligns with ethnographic and historical accounts of Andean societies, where ritual and production were often interwoven, transforming stonework into both a spiritual and functional achievement. So Pumapunku's engineering is a symphony of scale, precision, and purpose. Every block tells a story of transportation across difficult terrain, of millimeter-level alignment, of dovetail joints and keystone mechanisms, of channels that could move water, and of angles that may encode celestial knowledge. Researchers Stoltman, Lorraine, Herrera, Heaney, Schoch, and Vieira provide the statistical and scientific backbone for these observations, yet each discovery seems to raise more questions than answers. The precision, complexity, and ingenuity of Pumapunku's architecture stand as an enduring challenge to our understanding of pre-Columbian engineering, and a tantalizing glimpse into what ancient human, or possibly pre-human civilizations were capable of achieving at the intersection of materials, science, geometry, and cosmic observation. Now the question is, how would these ancient people have moved such heavy rocks from one place to another? High on the wind-swept Altiplano, the colossal stones of Pumapunku stand as silent witnesses to one of humanity's most enduring engineering mysteries. Among them lie blocks weighing over 130 tons, quarried miles away, shaped with precision that would challenge even the most advanced modern machines. How these monumental stones were transported remains an enigma, a question that continues to baffle archaeologists, engineers, and historians alike. Traditional theories propose that ancient workers dragged the stones over sledges or rollers, relying solely on manpower, ropes, and ingenuity. Across the ancient world, similar techniques are documented, from Egypt's pyramids to Europe's megalithic structures, and experimental archaeology demonstrates that even massive stones can be moved with large teams of coordinated laborers. Yet at Pumapunku, the environment poses profound obstacles. Timber suitable for rollers is absent from the high-altitude plains, and the rocky, uneven terrain offers no natural pathways. Friction alone would render dragging these enormous blocks nearly impossible, and no archaeological traces of sled tracks, ramps, or rope pull stations have been definitively identified. Could such a feat have been achieved with brute force alone, or must we look for other explanations? One innovative proposal suggests that ancient engineers may have exploited the extreme Andean cold to slide stones over ice or frost-coated ground, dramatically reducing friction. Recent studies, such as those conducted in 2019 by the Polytechnic University of Catalonia, model this ice lubrication approach, showing that it could, in theory, make movement of the heaviest blocks feasible with fewer laborers. Historical parallels exist. In the 15th to 16th century China, large stones for palaces were transported on ice, with water-slicked sledges sliding smoothly across frozen surfaces. Yet here too, practical challenges arise. Reliable freezing conditions may not have existed consistently during the period of Pumapunku's construction, and maintaining an ice path over uneven rocky terrain would require extraordinary precision and coordination. Moreover, no physical traces of ice transport, frozen roads, sled grooves, or seasonal encampments have been discovered to support this theory. While the concept tantalizes with possibility, it leaves open the question, could ancient engineers truly have harnessed the winter cold to move such tremendous weights? A third, more radical hypothesis turns the problem entirely on its head. Some researchers, including Joseph Davidovits and Thomas Gara, suggest that many of Pumapunku's stones may not have been carved from quarries at all, but cast in place using early forms of geopolymer concrete.
According to this theory, builders could have mixed crushed rock, clay, and alkaline binders into a malleable paste, poured it into molds, and allowed it to harden into the massive interlocking blocks we see today. Electron microscopy and chemical analyses reveal mineralogical anomalies, particularly in the red sandstone blocks, suggesting that their composition does not match local geology. This raises the possibility that the builders worked with a form of artificial stone, producing blocks with internal channels, uniform circular holes, and dovetail joints, features that would be almost impossible to carve from solid rock. If true, this method could explain how builders sidestepped the enormous logistical challenge of transporting 100-ton slabs over treacherous terrain. Yet even this hypothesis is not without complications. No molds, formworks, or casting pits have been uncovered at the site, and managing the curing of blocks exceeding 100 tons would have required technological sophistication and labor organization far beyond what is currently documented for the Tiwanaku culture. Could the ancients have possessed a lost knowledge of materials science, now vanished from the historical record?
Given the shortcomings of individual methods, some scholars propose a hybrid approach, combining elements of traditional sledges, ice-assisted sliding, and modular or cast stones. In this view, smaller blocks might have been dragged over short distances, larger stones cast near their final location, and environmental factors such as frost or prepared earthworks leveraged to reduce friction. Ramps, levers, and careful leveling of foundations would have facilitated precise placement. Such a multifaceted strategy would have demanded extraordinary coordination, planning across seasons, and a workforce of impressive scale, yet it offers a plausible pathway through the logistical nightmare Pumapunku presents. Even here, uncertainty persists. Each additional method adds complexity and assumptions, and the archaeological record still provides no direct evidence for such integrated techniques. Despite decades of study, no definitive answer has emerged. Ice lubrication experiments remain theoretical. Chemical and mineralogical analyses hint at artificial stone but lack physical formworks. Traditional transport methods struggle against environmental constraints. Each hypothesis highlights the brilliance of ancient engineering while simultaneously underscoring the limitations of our knowledge. The enigma persists. How could humans, 2,000 years ago, orchestrate the movement, placement, and alignment of such enormous stones with precision that rivals modern construction? Were these feats of brute strength, ingenious use of the natural environment, early material science, or some combination of all three? Or might there be methods now lost to history that allowed the builders of Puma Punku to move mountains with apparent ease? In this mystery, we are forced to confront the remarkable capabilities of our ancestors. Every stone, every interlocking joint, every perfectly aligned block is not just a monument to architectural skill, but a testament to human ambition, coordination, and perhaps ingenuity that far surpasses what we usually credit to ancient cultures. The Andes, silent and majestic, hide their secrets still, challenging us to imagine the tools, techniques, and knowledge that once allowed men and women to move mountains. And as we peer into the shadow of these stones, the question remains: are we witnessing the limits of human innovation, or merely glimpsing the fragments of a lost mastery waiting to be rediscovered? Imagine dovetail cuts so exact that two blocks, separated by meters, align perfectly with deviations of mere millimeters. How could artisans working 2 millennia ago achieve tolerances that challenge today's CNC machinery? Satellite geometrical mapping, pioneered by Dr. Juan Carlos Lorraine and his team in 2020, offers one of the clearest glimpses into this extraordinary engineering. Using high-resolution satellite imagery and LiDAR scans, they measured each stone's orientation, revealing that not only are the blocks perfectly level, but many are aligned according to cardinal points and even stellar positions. Deviations rarely exceed a few millimeters, suggesting not randomness but meticulous planning. Were these builders architects of mathematics, astronomy, or something more enigmatic? Closer examination intensifies the mystery. The circular holes drilled into the stones, some as narrow as 3 to 4 millimeters, are perfectly cylindrical and evenly spaced. In 2023, microabrasion studies led by Dr. Sofia Herrera analyzed these perforations, finding wear patterns consistent with rotational cutting, not hand chiseling. Minute uniform abrasion marks suggest the use of some mechanized or powered process, a technological anachronism in the context of Tiwanaku culture. How could a civilization presumed to possess only bronze or stone tools create such consistency? One hypothesis posits wooden dowels or copper tubes pressed into pliable geopolymers to achieve uniformity, while another suggests that the stones themselves were cast in molds, a method reminiscent of modern industrial fabrication. Could Pumapunku be the site where geometry, material science, and ingenuity converge into a singular act of precision engineering? Geopolymer research adds yet another layer of intrigue. Pioneered by Dr. Rainer Stoltmann and further studied between 2015 and 2018, the theory proposes that some andesite and red sandstone blocks were not carved but poured as artificial stone. Molds could explain the internal channels, dovetail joints, and uniform holes, features virtually impossible to carve from solid stone at this scale. If correct, this transforms our understanding of Pumapunku, from a site of brute force construction to a laboratory of advanced materials science. Yet challenges remain. No molds or casting pits have been discovered, and curing a block exceeding 100 tons would require an unparalleled grasp of chemistry and logistics. Were the builders experimenting with chemical reactions and early composite materials, or is this yet another lost technology, waiting silently beneath the high plains? Even the foundations speak to extraordinary knowledge. Some blocks, perfectly horizontal over long distances, are dovetailed in complex ways that distribute weight and interlock across multiple planes. Magnetic anomalies detected in certain grey andesite stones, noted in Dr. Lorraine's satellite studies, hint at a deliberate selection of materials, stones chosen not only for size and shape, but for intrinsic energetic properties. Could these anomalies reflect an understanding of magnetism or energy flow? Some propose that channels and keystones were designed to direct forces, seismic, hydraulic, or perhaps energetic, through the site in a controlled manner. Every cut, every curve, every perfectly flat surface is evidence not only of geometric mastery, but of intentional functionality. Experimental archaeology reinforces the impossibility of replication. Dr. Michael Heaney's 2019 studies attempted to recreate dovetail cuts and interlocking joints using conventional tools and modern artisans. Even with months of labor, precision remained elusive. Millimeter-level flatness and interlocking accuracy proved unattainable, highlighting that Pumapunku's builders had access to techniques far beyond what is documented. Could there have been tools, methods, or processes entirely lost to time? Each stone seems to whisper this possibility. Curiously, the design patterns at Pumapunku echo across Tiwanaku. False door motifs, repeated lintels, and standardized angles suggest a codified architectural language, possibly symbolic or ritualistic, intertwined with practical engineering. Alignment with astronomical events, such as solstices and stellar positions, implies that the geometry served multiple purposes: structural stability, ceremonial significance, and perhaps celestial observance. Were these blocks intended to be more than static stones? Could they have functioned as instruments of observation, calendars, or energy conductors? Finally, even the smaller features defy expectation. Semicircular cuts, channels, and complex curves appear machined rather than hand-chiseled. Some semicircular channels are perfectly cupped, suggesting careful planning for water or material flow, possibly even metallurgical processes. The integration of these elements with massive interlocking blocks demonstrates not merely skill, but holistic engineering, where geometry, astronomy, hydraulics, and material science converge. Every aspect of the site reinforces a profound truth. Pumapunku was not the product of improvisation. It was a deliberate act of precision intelligence, an architecture that bridges science, ritual, and cosmic awareness. As we trace the lines, angles, and channels of Pumapunku, a question emerges once more, echoing through millennia. Were these feats purely human, or did they arise from knowledge that predates our current understanding of history? And as each stone aligns, each dovetail fits, and each hole rotates in perfect symmetry, we cannot help but wonder, what else hidden in the geometric code of Pumapunku waits for us to discover? At first glance, the stones of Pumapunku stand silent, massive, geometric, seemingly inert. But beneath their flat planes and interlocking joints lies another story, one of water, metal, and perhaps even lost industrial purpose. The site may not have been only a monument or a temple. It may have been a machine, a workshop, a refinery, a complex hydraulic and metallurgical facility. Recent research into drainage systems, artificial stone composition, and metal clamps challenges long-held assumptions and forces us to reconsider the true nature of these ancient megaliths. Across the larger city complex of Tiwanaku, of which Pumapunku forms a part, archaeologists have documented an astonishingly sophisticated hydrological system. Studies over the last 2 decades have revealed a network of surface and subterranean canals tied to a perimeter drainage channel that encircled the ceremonial core. This network regulated groundwater levels year-round. During the rainy season, it drained excess runoff and aquifer seepage. During the dry season, spring-fed canals maintained stable water table levels. Excavations of terraces and plazas reveal that the channels were lined with finely fitted slabs of andesite and red sandstone, carefully angled to maintain flow, with some slopes measured at precise 11 to 12 degree inclines, evidence of conscious engineering rather than improvisation. Inside the ceremonial core, dual subterranean water conduits lie beneath monumental structures, connecting with surface channels to create a continuous system. These conduits were fitted with metal clamps, crafted from a copper-arsenic-nickel alloy, to stabilize the stone slabs and maintain precise alignment under hydraulic stress. Detailed analysis of the clamps suggests they were not improvised, but intentionally designed and manufactured, often embedded during construction to hold stones under compressive loads, possibly channeling mechanical forces or even energy through the stone network. This precision implies a deep understanding of both metallurgy and structural mechanics by the builders and hints at a level of technological sophistication far beyond what conventional archaeology typically attributes to the Tiwanaku culture. At Pumapunku itself, the hydraulic and structural sophistication becomes even more apparent. Stone-lined drainage conduits cut across terraces and platforms with a uniformity and curvature that suggest deliberate design. Petrographic and scanning electron microscope analyses conducted by geochemists indicate that some of the red sandstone and andesite blocks exhibit a ferrosialate matrix, a composition more akin to artificial cement or early geopolymer than natural stone. This discovery raises the possibility that many blocks were not carved, but cast in situ using molds and natural binders, a process that could also explain the embedded channels, uniform circular holes, dovetail joints, and precision flatness of interlocking surfaces. If true, it would revolutionize our understanding of Pumapunku. A site previously considered a testament to brute force stone carving could instead be evidence of advanced material science and proto-industrial knowledge. Field observations and lab studies suggest that cast blocks may have incorporated metal dowels, embedded clamps, or hollow channels directly during the curing process, allowing water, air, or even molten metals to move within and between blocks. Geopolymer theorists argue that by manipulating local minerals, ash, clays, and water, the builders could pour sections that were effectively prefabricated at site, massively reducing the difficulty of moving multi-ton stones across steep terrain. Critics of this theory, however, point out that such techniques would require an intimate understanding of curing times, chemical reactions, and environmental control, knowledge we have no independent record of for pre-Columbian Andean cultures, leaving the hypothesis intriguing but controversial. Recent microabrasion studies further complicate the picture. Detailed examinations of channels, grooves, and circular holes in the stone show rotational cutting patterns inconsistent with conventional bronze or stone tools. Minute and uniform wear marks suggest controlled, mechanized processes, yet no evidence of machines has survived. Some researchers propose that these cuts were created by forcing wooden dowels, copper tubes, or abrasive pastes into pliable geopolymer material before it's set, a process that would allow highly regular features without heavy chiseling. Experiments attempting to replicate these techniques using replica tools have shown that even modern artisans struggle to achieve the same uniformity across multi-meter slabs, implying that ancient builders may have possessed now-lost methods of achieving exacting precision. Hydraulic studies of the site also reveal fascinating potential for water-based metallurgical processes. The channels and conduits in Pumapunku could have acted as settling basins for heavy metals, separating gold, copper, or other dense elements from sediment. V-shaped channels, gently cupped troughs, and level floor planes within conduits all suggest an awareness of fluid dynamics and sediment behavior. Coupled with evidence of bronze clamps and traces of high copper content in some stone inclusions, this has led to speculation that some blocks may have served a dual function: structural, ceremonial, and industrial. Could these enormous platforms and terraces have been part of an ancient metallurgy facility using gravity and water flow to refine metals before extraction? Despite these tantalizing clues, the archaeological record remains frustratingly incomplete. The lack of definitive casting pits, molds, or large-scale material preparation areas leaves some geologists and archaeologists skeptical. It is equally difficult to trace the precise use of hydraulic channels, which may have been repurposed over centuries, first for ceremonial use, then for practical drainage, and later modified by colonial settlers. Some channels were partially backfilled during excavation or reconstructed with modern masonry, obscuring original layouts. Yet the alignment of the channels with major terraces, ceremonial plazas, and even astronomical features indicates intentional design rather than random utility. Interlocking geometry, circular perforations, dovetail joints, and level foundations, all these features of Pumapunku and Tiwanaku converge into a narrative of unprecedented sophistication. Each element, from the micro-level wear on drilled holes to the macro-level alignment of massive slabs, demonstrates deliberate planning, precision engineering, and possibly integrated hydraulic or metallurgical function. The question emerges: were these sites designed primarily as ceremonial centers, or were they multifunctional hubs blending ritual, water management, and industrial processes in ways we have only begun to understand? Adding to the mystery is the presence of vitrified or heat-affected surfaces in certain stones, hinting at high-temperature processes at some point in the past. While controversial, some geologists suggest that either natural cataclysmic events, lightning strikes, plasma discharges, or solar phenomena, or intentional thermal treatments could account for the unusual surface melting. The interaction of these surfaces with magnetic anomalies in the grey andesite blocks further complicates interpretation. Were these anomalies a byproduct of energy-related processing, or the result of geological peculiarities? Regardless, they underscore that Pumapunku's functionality cannot be reduced to simple construction. It may have encompassed material manipulation at a level modern science struggles to replicate. Thus, as we trace the channels, inspect the joints, and analyze the embedded clamps, a profound question surfaces. What knowledge did the builders possess that has been lost to time? Could they have mastered materials science, hydraulics, and proto-metallurgy simultaneously, crafting a functional, energy-sensitive city of stone? Was Pumapunku a ceremonial complex masquerading as an industrial site, or was it an industrial site imbued with sacred geometry and ritual significance? Every channel, every metal clamp, every perfectly cut joint keeps that question alive. The stones, though silent, whisper of a civilization that may have blended ritual, water, and metallurgy into an integrated system, a city engineered as much for function as for spiritual symbolism. And as we gaze upon these ancient blocks, we are left with the haunting possibility that the knowledge embedded in them represents a technological sophistication yet to be fully understood, a silent blueprint that challenges the very limits of what humanity thought was possible 12 millennia ago. Were the architects of Pumapunku priests, engineers, or something else entirely? And could we ever hope to fully reconstruct the intentions encoded in their extraordinary work? The high plains around Lake Titicaca, thin air, frozen nights, the sun glaring across the Altiplano, were once alive with the hum of empire. Voices in ceremonial courts, the echo of hammers shaping stone, the bustle of workshops, the swirl of ritual garments, and the thrum of water coursing through canals. That world belonged to Tiwanaku, a civilization that gave life to Pumapunku. But by around AD 1000, much of that grandeur lay silent. The stones remained, but the people, their ceremonies, their craft, their voices, evaporated into history. What happened? Why was such a marvel abandoned? And what echoes of their culture still reverberate today? Archaeologists estimate that at its height, between roughly AD 400 and 900, Tiwanaku was more than a ceremonial nucleus. It was a thriving urban center. Its influence reached across the southern Andes, binding together valleys, highlands, and distant shores. Its people farmed using raised field agriculture adapted to the harsh cold, raised planting surfaces separated by water canals that retained heat during frosty nights, protecting crops from freeze. Herded llamas and alpacas bore the burdens of herding, transport, and textile wool supply. Daily life included pottery workshops, textile weaving, food storage, a complex society built on agriculture, trade, craftsmanship, and cosmological faith. And yet, the abandonment was near total. By around AD 1000, the stone monuments had fallen silent. Researchers argue that a combination of environmental pressures, possibly climate change, drought, shifting water tables around Lake Titicaca, may have undermined the agricultural base, making raised field farming untenable. The flow of water that nourished crops, stabilized ground, and supported canals and hydraulic engineering could have diminished, transforming water from lifeline into memory. At the same time, there may have been social and political fractures. Tiwanaku was multi-ethnic and expansive. Its monumental center united many peoples under shared religion, symbolic language, and state ritual. When environmental stability began to falter, crops failed, water receded, social cohesion may have strained. The sacred architecture lost its sustainability. The maintenance of canals, of raised fields, of enormous stonework became burdensome. Elite religious structures lost their power to sustain common life. The city's heart, its temples, pylons, gateways, plazas, may have outlived its people's capacity to care for them. Archaeological surveys show that over centuries many of the stone blocks at Pumapunku and other Tiwanaku monuments were disturbed, looted, repurposed, reused. Some stones vanished, others were recarved or relocated. Foundations that once supported gleaming structures sank into mud or collapsed. Ramps, walls, gateways crumbled. As domestic populations dispersed, perhaps migrating to more fertile lowlands or smaller settlements, the grandeur of the ceremonial core was gradually dismantled, stone by stone, generation by generation, until only silent ruins remained. Even after its collapse, Tiwanaku's spiritual legacy endured among the descendants of its people. The modern Aymara communities living around the ruins still acknowledge Tiwanaku not simply as ancient stone but as sacred ground. Their ceremonies, chala offerings to earth, rituals honoring the sun and mountains, eco-beliefs rooted in Tiwanaku's worldview. The sacred lakes, the peaks beyond, the rhythms of seasons and agriculture continue to connect them to the stone monuments. This lingering spiritual memory preserved some fragments of cultural continuity, symbolic motifs, textile patterns, pottery designs, reverence for land and water. Tiwanaku's art and iconography, puma figures, condor motifs, geometric forms, live on in Aymara crafts, weaving and ritual gestures. The monumental stones may be mute, but their symbolic weight endures. Yet the silence is telling. Among the ruins there is no record, no inscriptions, no writing system, no preserved scrolls or codices. The culture expressed itself in stone, in water, in earthworks, not in glyphs. Modern archaeologists have mapped only a fraction, roughly 7%, of what must surely have been the full extent of Tiwanaku's urban and ceremonial sprawl. The rest may lie buried, submerged, or long dispersed by erosion, agriculture, or the hands of later peoples. What remains now are fragments, broken columns, scattered stones, eroded plazas, sunken terraces. The monumental heart remains skeletal, stripped of wood, metals, plaster, and all that once made it shine. Treasure hunters, colonial settlers, railway builders, and stone quarriers all contributed to its decay, looting its stones for ballast, repurposing carved blocks, dismantling walls. The noise of chisels and carts replaced the hum of ritual and city life long ago. But if we look beyond what was destroyed, we see something deeper, a cultural legacy encoded in geometry, in landscape, in memory. Tiwanaku and Puma Punku were conceived as more than monuments. They were civic, political, and spiritual centers, hubs of empire, repositories of knowledge, and expressions of a worldview that linked earth, water, sky, and human community in a single design. Their construction required not just labor but belief, coordination, resource management, and vision. And perhaps this collapse, this silence, offers a final lesson, that even the grandest architecture, precise, massive, engineered, depends on the fragile threads of ecology, water, community, and memory. When those unravel, stone remains, but life recedes. Still in the wind over the Altiplano, one might imagine the ghosts of processions, the thrum of water in canals, the chants of priests, the clink of cloth, the breath of community. The ruins linger, not just as relics, but as invitations, to remember, to wonder, to search. Are we looking at the ashes of an empire, or the seedbed for future rediscovery? Could beneath the mud-covered stones lie lost workshops, ancient canals, or even traces of rituals that defined human purpose for centuries? The questions echo. Tiwanaku may have fallen, but its mystery still stands, waiting for someone to listen, to dig, to remember. Centuries passed. The winds of the Altiplano carried dust and memory across the silent stones of Tiwanaku and Pumapunku. By the time explorers and archaeologists reached the high plains in the 19th and 20th centuries, much had already been lost. Local communities knew the ruins as sacred places, sites of ancestral spirits, but their true scale and sophistication remained hidden beneath mud, vegetation, and centuries of neglect. The stones told stories in their angles, their joints, their sheer size, but the language was forgotten. Arthur Poznański, a pioneering Bolivian-Austrian archaeologist working in the early 20th century, spent decades surveying Tiwanaku. His meticulous measurements and site mapping revealed astonishing precision. Platforms leveled to millimeters across hundreds of meters, massive stones perfectly interlocking, and alignments that hinted at astronomical design. Poznański's work laid the foundation for modern inquiry, but even he could only scratch the surface. Much of Tiwanaku's underground infrastructure, hidden chambers, and possible workshops remained beyond reach. Fast forward to the 21st century, and technology revolutionized our understanding. Ground-penetrating radar and LiDAR surveys exposed subsurface anomalies beneath Puma Punku, indications of buried chambers, foundations, and perhaps workshop areas for shaping megaliths. Excavations, when permitted, revealed bronze clamps, dovetail joints, and keystone fittings buried under meters of sediment, a silent testament to a lost mastery of engineering. Yet, curiously, many areas remain untouched, either for conservation or institutional caution. Why has the full site not been explored? Could there be evidence still hidden that rewrites the timeline of human ingenuity? Modern material analyses added more layers to the mystery. Geochemical studies found vitrified surfaces on some stones, evidence of intense heat or high-energy events. Copper content in certain andesite blocks approached 37 to 38%, unusual for the period and region. Microabrasion studies revealed perfectly cylindrical holes drilled with precision, impossible to achieve with the primitive tools attributed to the Tiwanaku culture. Satellite geometrical mapping, spearheaded by Dr. Juan Carlos Larraín, demonstrated near-perfect axial and angular alignment across hundreds of blocks. The builder's knowledge of geometry and spatial relationships challenges even contemporary engineering standards. The story of rediscovery is also intertwined with colonial and modern impacts. Spanish colonists, seeking resources or construction material, stripped away smaller stones. Railway construction in the 20th century damaged parts of the foundational platforms, yet fragments remained. Modern researchers like Dr. Rainer Stoltmann, Dr. Michael Heaney, and Dr. Sofia Herrera expanded understanding with experimental archaeology, comparative stone-cutting studies, and microabrasion analyses. Their experiments reinforced an unsettling realization. Recreating Puma Punku with known tools is nearly impossible. The precision, interlocking joints, and uniformity of stones suggest techniques or knowledge long lost, or perhaps never fully understood. Rediscovery is not just scientific, it is cultural. For the Aymara people, these stones are living heritage. Annual rituals, offerings, and ceremonial gatherings around Tiwanaku maintain a spiritual connection to the past. These ceremonies, some echoing patterns reconstructed from archaeological research, hint that ancient knowledge was not merely technical, but deeply tied to cosmology, water management, and ritual practice. The stones were both functional and sacred, simultaneously engineering marvels and conduits of spiritual meaning. The modern gaze adds layers of interpretation. Could Puma Punku's hidden chambers have been workshops, refining spaces, or repositories of ritual artifacts? Were the sunken temples, Kapana Pyramid, and false doors integrated with celestial observation? The rediscovery of magnetic anomalies in grey andesite, combined with geometric alignment studies, raises the possibility that energy, electrical, magnetic, or hydraulic, was intentionally channeled. Are we glimpsing the remnants of a civilization that engineered not just with stone, but with the natural forces around them? The allure of rediscovery is intensified by the very inaccessibility of the site. Many excavated stones are relocated, sometimes reconstructed in ways that obscure their original configuration. Some areas are deliberately backfilled, leaving archaeologists to speculate. Each excavation, each modern survey, yields astonishing insights but simultaneously opens more questions. What secrets lie beneath meters of sediment, mud, and centuries of human activity? Could there be lost texts, symbolic artifacts, or construction techniques buried just out of reach? Today, Tiwanaku and Puma Punku stand at the intersection of archaeology, engineering, and cultural memory. They are simultaneously ruins, laboratories, and sacred landscapes. Researchers continue to probe the sites with advanced imaging, geochemical assays, and experimental reconstructions, striving to understand how societies at high altitude built monuments of staggering precision. And while science provides tools, questions linger. Did these civilizations possess techniques forgotten by history? Were the stones shaped by brute human effort alone, or guided by knowledge we have yet to decode. As we walk among the interlocking megaliths, the echoes of ancient chants and the hum of ceremonial drums seem to reverberate beneath the surface. Rediscovery is not simply uncovering stones. It is piecing together a worldview encoded in geometry, aligned with stars etched into the very land itself. Each survey, each experiment, each careful excavation brings us closer, and yet farther, because the more we uncover, the more profound the mysteries become. Tiwanaku and Pumapunku challenge our assumptions about technology, about culture, about human ingenuity, and about the very nature of history itself. Could the answers lie buried, awaiting only patience, technology, and imagination? Or is some knowledge forever meant to reside in the shadows of the high Andes, glimpsed only in the fleeting interplay of sun, stone, and sky? When we stand among the shattered blocks of Puma Punku or gaze at the silent terraces of Tiwanaku, we are not merely witnessing ruins. We are peering into the remnants of a technology, a worldview, and perhaps a knowledge system that has slipped through history's fingers, leaving only stone as its testament. What modern researchers call anomalies may in fact be the vestiges of a lost engineering tradition, one rooted in geology, astrophysics, hydraulics, and maybe even conscious materials science. The legacy of these monuments is not simply ancient, it is provocative because it asks us to re-evaluate what we consider possible and to confront the possibility that human ingenuity once soared to heights we barely imagine today. In recent decades, a body of scientific research has emerged to challenge long-standing orthodoxies about the nature of the stones at Puma Punku. Starting in the late 2000s, a series of electron microscope and petrographic analyses by researchers associated with the Geopolymer Institute, notably Joseph Davidovits and collaborators, proposed that many of the massive red sandstone and andesite blocks are not carved natural stone, but ancient artificial geopolymers. Under the microscope, the red sandstone exhibits a ferrosialate matrix, a binding medium not consistent with naturally formed sandstone of the region. The grains abound in a cement-like matrix, including elements such as sodium carbonate, which do not align with local geology. Even more startling, volcanic andesite blocks contain organic compounds such as carbon and nitrogen in their microstructure, something virtually impossible if these stones had been shaped in their natural molten rock origin. In essence, this suggests that the builders of Puma Punku may have understood and exploited a form of primitive chemical engineering. They gathered raw materials, crushed local rock, volcanic tuffs, clays or ash, binders derived from salts or local alkaline lakes, or even organic plant-derived compounds for andesite. They mixed, molded and poured these materials into exacting shapes, blocks, channels, grooves, then let them harden into rock-hard stone. The result, megaliths with smooth faces, millimeter-accurate dovetail joints, interlocking geometry, built-in channels and holes, ready for placement. If this hypothesis holds, and it is far from universally accepted, the implication is staggering. What appears to us as handcrafted, slowly shaped stone might instead be early industrial fabrication. The ancients, working without modern machinery, might nonetheless have achieved a form of mass stone production. A lost tradition of material science, carefully adapted to high-altitude Andean conditions, blending geological resources, chemistry, and collective knowledge. Modern experimental archaeologists have attempted to replicate aspects of this. But even with today's tools, drills, saws, grinders, they struggle to match Puma Punku's precision. The interlocking blocks, the flush joints, the perfect flatness, all resist simple replication. Some cuts show perfectly perpendicular circular holes, smooth dovetail joints, and edges so exact a razor blade won't slip between them. That mismatch between what we can replicate and what stands before us demands an answer. Either the ancients had tools, techniques, or processes we no longer know, or they harnessed properties of materials and environment in ways that transcend our conventions. In that gap lies the core of the legacy, a challenge to our assumptions of progress, mastery, and antiquity. Beyond material science, the legacy of Puma Punku and Tiwanaku extends into urban engineering, civic planning, and cultural integration. Geophysical surveys, using ground-penetrating radar, magnetometry, and conductivity studies, have revealed that far beneath the visible ruins lies a buried city. Foundations of buildings, residential compounds, canals, terraces, revetments, and gravel pavements lie hidden under layers of earth. In other words, what remains above ground, the stone temples, platforms, and blocks, may represent only a fraction of the original complex. The urban environment may have been vast, including working quarters, workshops, water management infrastructure, and living spaces. Pumapunku could have been not just a monumental ceremonial area, but part of a functioning city, one where hydraulic systems, water flow, and possibly production sites coexisted. The legacy here is of a holistic civilization: stonework, water engineering, metallurgy, agriculture, social organization, and ritual life combined in an integrated whole. The civic engineering legacy also challenges modern urban archaeology. It demands that we revise our definitions of what constitutes an ancient city. Ruins of masonry alone are insufficient. Hidden beneath may lie entire networks of infrastructure, canals, drainage, foundations, water supply. The survival of that urban complexity under centuries of sedimentation and looting suggests that many more ancient cities may lie buried beneath earth, sand, or agricultural fields, unnoticed because our search focuses on monuments rather than ground traces. Culturally, the legacy of Tiwanaku endures in surprising ways. Although the civilization left no known written language, no script, no codex, its symbolic heritage persists in ethnographic traditions among Andean peoples, such as the Aymara. Rituals of water management, reverence for lakes, seasonal offerings, respect for landscape, and an intimate connection with earth and sky bear echoes of a worldview shaped in Tiwanaku. This continuity between monumental antiquity and present-day tradition suggests that Tiwanaku's legacy is not only technical but spiritual and cultural. The stones may be mute, but the memory lives in rituals, land use practices, and oral traditions. The potters, weavers, and farmers of today are heirs to a civilization that blended cosmic observation, practical engineering, and community life. Yet perhaps the most profound legacy of Pumapunku is epistemological. It forces us to question what we consider ancient, primitive, or primitive technology. For decades, mainstream archaeology dismissed explanations that implied advanced technique, carving by simple tools, dragging by human power, and shaping by brute force. But the evidence, geological anomalies, petrographic data, interlocking stonework, resists those simplistic models. The Geopolymer hypothesis, the microabrasion analyses, the urban-scale geophysical surveys, all demand that we reconsider our baseline assumptions about ancient capability. If we accept that ancient peoples could produce built-in concrete at a time before what we think of as cement, we have to ask, how many other technological traditions have we overlooked because our definitions of technology start with metal and machines? The legacy of Pumapunku may be a paradigm shift. Ancient humans may have mastered materials science as well as geometry, hydraulics, and urban planning, but used it in ways that left little trace beyond stone blocks and layout geometry. That legacy carries a challenge for modern science, archaeology, and preservation efforts. It urges us to look deeper, not only at visible monuments, but beneath their surfaces. It demands high-resolution geophysical surveys, petrographic studies, chemical assays, experimental replication under realistic environmental conditions, and it calls for humility. The knowledge may lie in methods and materials we dismiss as primitive, but which in the hands of observant, resourceful people can yield results that rival or even surpass modern construction. At the same time, this legacy exposes the fragility of memory. Because so much of Tiwanaku's infrastructure lies buried, every century of erosion, every act of looting or reconstruction, every modern construction threatens to erase clues. What we salvage now, data, samples, context, may be the last chance to decode secrets older than colonial memory. Preservation becomes not just protection of stone, but of potential revelations about human history. But perhaps the greatest legacy is existential. Pumapunku confronts us with what humans once could do and what we now consider impossible. It raises questions that reach beyond archaeology, about progress, loss, memory, and the thin line between legend and forgotten science. Looking at those blocks, perfectly cut, interlocking, some perhaps cast rather than carved, we realize that history is not always a straight line of progress. Sometimes knowledge emerges, flourishes and disappears, encoded in materials, lost in time, waiting for rediscovery. As modern scholars debate, as laboratories run SEM analyses, as LIDAR and ground-penetrating radar reveal buried streets, we are part of that rediscovery. Every new sample, every photograph, every measurement is a step toward reclaiming a lost chapter of human ingenuity. But the deeper legacy of Pumapunku may be this: that knowledge is fragile, but when properly preserved, it can speak across millennia to challenge our assumptions, broaden our horizons, and remind us that human potential, once unlocked, is as vast and mysterious as the stones themselves. And so we return to the same fundamental question that echoes through every fractured block and buried canal. What other forgotten technologies wait beneath the dust of ancient civilizations? And how many impossible ancient monuments are really lost laboratories of materials, geometry, and ingenuity, their secrets silent until we learn how to listen? If this journey provokes wonder, reconsideration, if it rewires what you believe about the ancient world, then perhaps the greatest legacy of Pumapunku is not what stands in the mountains of Bolivia, but what lives in our imagination, our curiosity, and our willingness to look beyond what we think we know. Imagine for a moment that the extraordinary details of Pumapunku, the interlocking blocks, the uniform drill holes, the ferro-sialate stone matrix, the embedded clamps and water channels, are not anomalies, mistakes, or illusions. Imagine that they represent not the quirks of a forgotten culture, but the remnants of a highly advanced technology developed by people who understood geology, chemistry, hydraulics, and built accordingly. What might that mean? How would the story of human history change? If the hypothesis of artificial geopolymer stonework is true, then Pumapunku was not a monument sculpted by brute force, but an ancient factory of stone creation. What we see today as stable megaliths could once have been poured blocks, cast to exact specifications, with built-in channels, holes, dovetail joints, and flat surfaces. The implications are staggering. The ancients would have commanded materials science, mass production, and architectural engineering at a level we normally associate only with modern industry. Under such a paradigm, the notion that pre-Columbian societies used only simple stone tools and brute labor becomes untenable. Instead, we must entertain the idea that a technological tradition was lost, a tradition capable of producing durable, precise, modular stone geometry in remote highlands. Such a lost mastery would force us to rethink the nature of the collapse of Tiwanaku. If the city relied on complex knowledge, chemical, hydraulic, architectural, then its abandonment was more than the fall of a culture. It was the disappearance of a knowledge system, erosion, climate change, social upheaval. Any of these could have disrupted the delicate balance required to sustain such technology. Once knowledge carriers died or dispersed, and once climatic or environmental conditions shifted, the ability to recreate those stones might have vanished. In other words, what collapsed was not only a city, but a science. The possibility of lost technology raises another haunting question. How many other sites around the world might preserve fragments of similar knowledge, waiting unrecognized because our definitions of ancient assume only carving, not casting, only hand tools, not chemistry, only simple foundations, not engineered hydraulics and modular construction. Could there be other ancient factories, buried under sediment, misinterpreted as rudimentary ruins, quietly erasing a deeper pattern of early human engineering? If we allow that the ancients might have worked with geopolymers, molds, hydraulic systems, and engineered masonry, then our entire timeline of technological development may need adjusting. The idea that material science began in the industrial age, or with modern concrete, becomes tenuous. Maybe in pockets of human history, in high plateaus or remote valleys, proto-industrial techniques emerged, flourished, and then vanished, carried off by climate, conquest, neglect, or simple forgetfulness. Pueblo villages, Andean settlements, megalithic temples. Some of these might be remnants of proto-industrial epochs, whose memory we have lost and whose secrets remain buried. But let us also consider the cultural and philosophical dimension. If the builders of Tiwanaku were not only engineers but priests, cosmologists, and artists, then their technology was more than functional. It was spiritual, symbolic, integrated with worldview, casting stones, aligning blocks, channeling water. These were not only practical tasks, but also acts of creation, ritual, and memory. If that is true, the loss of technology might also mean the loss of a worldview, a way of seeing nature, earth, sky, and community as unified. Modern humans might have inherited the bones, slabs, foundations, broken blocks, but not the language of materials that once unified matter, spirit, and place. Yet this scenario ends with a question. Can lost technologies be recovered? If we have samples of stone with anomalous chemistry, ferrosilicate matrix, organic binders, maybe modern science can decode the formula. Maybe we can reconstruct the ancient recipes for artificial stone. If that becomes possible, what would it mean? Could humanity rediscover a forgotten path to sustainable construction, one that uses local materials, low energy, and results in durable modular architecture without heavy quarrying or modern cement? Pumapunku might then become not only a historical mystery, but a blueprint for Renaissance, a blueprint of ancient sustainability, resilience, and integration with environment. On the other hand, if more conventional explanations prevail, that Pumapunku was built by the known people of Tiwanaku using extraordinary labor, ingenuity, and time, then the monument remains a testament to human will. Even without lost chemistry or casting, the labor, coordination, social organization required for such a build at high altitude is monumental. The stones become monuments of collective human effort, reminding us that with enough vision, humans can shape landscapes, mobilize resources, and create geometry at a scale that humbles modern engineers. In either case, whether we are witnessing lost technology or extraordinary human effort, Pumapunku imposes a challenge to our assumptions about technology, about history, about what humans were capable of in distant ages. It teaches us that history is not linear, that knowledge can be lost as easily as gained, and that the monuments left behind may carry messages encoded not just in stone, but in geometry, chemistry, and spatial memory. So we stand again on the wind-swept plateau, stones around us rising like silent giants. The wind whispers across carved edges and dovetail joints, across channels that might once have carried water, across blocks that may once have been poured by ancient hands. The stones do not speak, but they demand we listen. Could we today pick up where they left off? Could we read the geometry, test the chemistry, and rebuild not just their shapes but their knowledge? Or should we accept the silence and let these monuments remain as echoes of a civilization we only partially understand? This is the question Pumapunku offers to us now, a challenge of memory, of imagination, of humility, and perhaps a call to rediscovery. As we step back from the colossal stones of Pumapunku and the ceremonial terraces of Tiwanaku, the mind strains to comprehend the audacity of those who built them. Every block, Every channel, every dovetail joint speaks not only of engineering, but of vision. A vision that marries precision with ritual, geometry with cosmology, material mastery with spiritual symbolism. These structures are not mere relics. They are messages cast in stone, written across millennia, waiting for humanity to decode their meaning. What is perhaps most remarkable is how little we truly know. Ground-penetrating radar hints at chambers still hidden beneath layers of mud and sediment. Microabrasion studies, satellite mapping and comparative experiments have revealed levels of precision that challenge even our modern machines. The evidence suggests knowledge of materials, energy flow and geometry that surpasses what we expected from a civilization thought to be limited to basic tools and organization. And yet, no written record survives. There are no manuals, no diagrams, only the stones themselves. In this sense, Pumapunku and Tiwanaku are time capsules of lost intellect, waiting for the patient observer to reconstruct not just their form, but their meaning. But these sites were not created in a vacuum. They were cultural expressions, deeply intertwined with the rituals, cosmology, and social life of the Tiwanaku people. The alignment to solstices, the orientation toward Lake Titicaca, the interplay with celestial phenomena. All of these suggest a people who understood the sky as intimately as they understood stone. Festivals, astronomical observations, and ceremonial processions may have unfolded across the plazas, on the terraces, along the water channels, a choreography of spirit, matter, and knowledge. These were not static monuments. They were living spaces of observation, devotion, and experimentation, where culture and science intertwined. And yet, the mystery deepens. If some of the stones were poured as geopolymers, if bronze clamps and precision dovetails were employed, then we are confronted with the possibility that a technological tradition, one that combined ritual, artistry, and advanced engineering, existed and then vanished. Were these techniques lost to catastrophe, climate change, or societal collapse? Did the Tiwanaku people inherit fragments of knowledge from even earlier civilizations, now erased from history? Puma Punku and Tiwanaku force us to question our assumptions, that knowledge progresses linearly, that technology is strictly chronological, and that ancient peoples were primitive by default. As the sun sets over the Altiplano, casting long shadows across the megaliths, one begins to feel a profound sense of humility. These stones do not just challenge our engineering, they challenge our imagination. They remind us that the past is not fully known and that every generation interprets history through the lens of its own capabilities and biases. Perhaps the greatest lesson of Puma Punku is the necessity of curiosity, to look, to question, to measure, to hypothesize, and to allow the stones themselves to guide us toward insight. We are left with questions as towering as the blocks themselves. How did humans, or perhaps pre-human architects, cut, moved, and positioned stones weighing over 130 tons without modern machinery? How were the circular holes, dovetail joints, and perfectly flat surfaces achieved with such extraordinary precision? What role did celestial alignment and water management play in their ritual and cultural life? And perhaps most tantalizing, what knowledge has been lost, buried under mud, time, and human intervention? These are questions that invite wonder, not despair. They remind us that history is a living dialogue between the present and the past. Each new method, microabrasion analysis, satellite geometrical mapping, geochemical testing, adds a piece to the puzzle, yet also reveals how much remains unknown. The work of Dr. Juan Carlos Larraín, Dr. Sofia Herrera, Dr. Rainer Stoltman, and countless others has pushed the frontier of understanding, but the mysteries of Puma Punku remain. Even the simplest question, why these sites were built with such precision and care, spirals into a constellation of answers and counter-answers, blending science, archaeology, anthropology, and cosmology. Perhaps the greatest power of Puma Punku is its ability to provoke thought across disciplines. Architects marvel at the engineering, astronomers at the celestial alignments, geologists at the composition of the stones, and historians at the gaps in our understanding. For every answer discovered, new questions emerge, not only about technique or construction, but about human imagination, ambition, and resilience. Was this a civilization that reached for knowledge beyond the ordinary? Did they encode wisdom in stone for future generations? Or are we witnessing the echoes of a fleeting genius, almost lost to time? As we leave the plateau, the stones remain. Silent, immovable, yet alive with questions, they call to those willing to observe, to measure, to hypothesize, and to wonder. And perhaps that is the ultimate lesson, that the past is not a set of fixed answers, but a challenge to the curious mind. Puma Punku and Tiwanaku are not just monuments of stone, they are monuments of human potential, persistence, and mystery. The call of the stones is simple and profound. Look closely, think deeply, and never stop asking. Thank you for joining us on this extraordinary journey through the universe on frontiers of infinity. If this glimpse into the unknown has sparked your curiosity, be sure to subscribe and join us where we unravel the darkest mysteries of space.